Hello, I'm Brusudan Sertsvadze from Sisvadzebi Public School. I'm ninth grader. I want to present you how we can investigate the quadratic function in the GeoGebra program using a resource created by my teacher. Slides are given with which we can change a coefficients of the quadratic function, and on the graph we can observe how each change transforms the parabola. Here we have the general equation of the quadratic function. Y is equal to ax squared plus bx plus c. We will look at special cases of the quadratic function using slides. The location of the graph of the quadratic function is determined by the discriminant. The location of the graph of the quadratic function is determined by the discriminant. It is a discriminant. Discriminant is equal to b quadrats minus 4ac. Using the program, we can observe how the determinant changes. By looking at the discriminant and the coefficients, we can find out the location of the parabola with respect to x-axis. During the study of the quadratic function, it is also important to determine the coordinates of the vertex of the parabola, which is helped by the coordinates of the vertex of the parabola calculated by the program. Let's observe how the change of the coefficients affects the location of the parabola. A is greater than 0. The branches of the parabola are directed upwards. A is less than 0. Then the branches of the parabola are directed down. A is equal than 0, then we no longer have quadratic function, and we have the linear function. So we can conclude that A shows where the branches of the parabola are directed. B is less than 0. In the cases, the graph will move the right. B is more than 0, and in the case, the shadow will move to the left. So it turns out the coefficients B shows on which sides of the y-axis the vertex of the parabola is located. C is more than 0, so the shadow will rise up the C units. t is less than 0. In this case, the schedule will go down by t units. So, the coefficient shows where the parabola crosses the y-axis. After this, let's consider different cases. Number 1. A is more than 0 and discriminant is more than 0. Branches are directed up. Schedule crosses the x-axis. Parabola has two common points with x-axis. Number 2. A is more than 0 and discriminant is equal to 0. The branches are directed up. The schedule's top is located on the x-axis. So schedule has one common point with x-axis. Number 3, A is more than 0 and discriminant is less than 0. Branches are directed up. The schedule is located over the x-axis. Function has no 0. Okay, number 4. A is less than 0, discriminant is more than 0, schedule crosses x-axis, branches are directed down, and function has two zeros. Okay, next, number 5. A is less than 0, discriminant is equal to 0, the schedule has one common point, branches are directed down, function has one zeros. Next is number 6. A is less than 0 and discriminant is less than 0. The branches are directed down. The schedule does not cross the x-axis. Function does not have zeros. Okay, we can find out the range of values of the function in each when consider cases intervals of growth and this line intervals of line considers coordinate of the vertex of the parabola and the largest and smallest value of the function. Thank you for your attention.